Hi everyone, hope you all are fine. Myself Sugesh K. Bhaskaran, Senior Mechanical Engineering Consultant, back again with another beautiful presentation. This presentation is intended to give you more clarity about my last presentation, a chilled water system that is cheaper than a VRF system. When the last presentation hit the market, I started getting a lot of calls regarding the diversity, block load and so on. Before explaining the difference in heat load using technical terms, I will tell you an easy way to understand the difference in capacity of the chiller plant. Take your car and go to any chilled water plant in peak load condition. If there are 3 chillers installed in the plant room, then only one chiller is working, and if there are 5 chillers installed in the plant room, then only 2 chillers are working. From this we can see that the chilled water system installed in our building is 2 or 3 times more than the actual requirement, larger than the actual capacity. It is very clear from this that we can design a very good energy efficient chilled water system along with significant financial gain. Now let us illustrate the same with proper calculations. Let us discuss the thermal conductivity of the partition wall. Rho is the thermal resistance of the outside air film and Ri is the thermal resistance of the inside air film. Rho for the wall is 0.059, Ri for the wall is 0.121. Let us now consider a hollow core concrete block with a thickness of 200 mm and thermal resistance of 1.130. We also need to consider on both sides a 15 mm thick cement plaster with a thermal resistance of 1.750. Let us now look at the Excel sheet calculation for the thermal conductivity of partition walls. From these calculations, we have a total thermal conductivity of 2.181 watt per meter square degree Celsius. Let us look into the thermal conductivity of the floor and ceiling. Rho for the floor and ceiling is 0.059, Ri for the floor and ceiling is 0.166. Let us now consider reinforced concrete PT slab with a thickness of 200 mm and thermal resistance of 0.40. We also need to consider a 30 mm thick cement plaster with a thermal resistance of 1.750. From these calculations, we have a total thermal conductivity of 2.80 watt per meter square degree Celsius. Now we can calculate the temperature of the partition wall, floor and ceiling using virtual environment software. From this simulation report, we can see that the partition temperature is 34.57 at peak load conditions. It is safest to keep the partition temperature at 35 degrees Celsius to ensure cooling in all conditions. For comparison, however, we can take the partition temperature to be 33 degrees, 2 degrees lower than the simulation report. If the lower and upper floors are not air conditioned, for 2 days, the lower and upper floors will easily reach 33 degrees Celsius. So, as a designer, it is safe to consider partitions when making calculations to ensure cooling. Many designers make mistakes in calculating thermal conductivity values and partition temperature, which can lead to lower capacity than required. This also leads to cooling issues. An office building operates when nearby offices are closed during the holidays. During the holidays, the occupants of the next flat close the flat and leave, while the occupants of one flat stay at home without going anywhere. In these similar situations, if we do not consider the partitions properly, cooling may fail to achieve. I have already prepared space in the hourly analysis program for the actual comparison of heat load. Let us go to System and run the program to get the total heat load of the VRF outdoor unit. As I like to compare the actual VRF outdoor capacity with the actual chiller capacity, I do not consider any difference in the number of occupants, equipment load, lighting load, etc. Currently, the VRF outdoor unit capacity is 24.8 cooling kilowatt, that is 7.05 TR according to HAP calculations. Now I am going to remove the floor and ceiling partition area from my calculations. I do not consider partitions within the floor for comparison, as VRF manufacturers try to convince the market that all floor apartments, offices can be connected to a single outdoor VRF unit. The difference in capacity will be more if I consider the partitions within the floor. As a consultant, I advise you by considering many technical matters. If you are going through a VRF system, it is better to connect an apartment or an office with a dedicated VRF outdoor unit. Now, let me duplicate the space in the hourly analysis program. Change the name of the space flat chiller. Let us just remove the floor and ceiling partition for comparison. Let us go to System and duplicate the system, change the name to flat chiller. Now you can change the space into flat chiller and run the program to find the total heat load contribution to the chiller unit. Currently, the contribution to the chiller unit is 15.1 cooling kilowatt, that is 4.29 TR according to HAP calculations. That is around 40% less than the required VRF capacity. Remember, here we do not consider the partition area between the apartments and the partition area between the apartments and the corridor. That is, the partition area within the floor is not considered. When this is taken into account, the percentage difference will be furthermore. This comparison is with the actual capacity of the VRF outdoor unit and the actual capacity of the chiller. Many in the industry have asked what is the impact of diversity on heat load calculations on total capacity. Let us look at the diversity in occupancy. If our calculation is done using split units, then let us see what is the total occupancy. Bedrooms, 2 number of people, 3 bedrooms, 6 number of people. Living and dining with 12 number of chairs, total 12 number of people. Kitchen, 1 person, total number of people 19 numbers. VRF outdoor capacity, maximum number of people 12 numbers. Considering the situation with guests or the total number of chairs in the living room. Split unit to VRF, the reduction is from 19 numbers to 12 numbers of people. The chilled water system has 408 apartments with 12 number of people. 4,896 people are very high in one building. Here we can consider the diversity. It is enough to consider only 5 to 6 people for an apartment. Now change the number of people in space from 12 to 6. Let us go to system and run the program to find the total heat load contribution to the chiller unit. Currently, the contribution to the chiller unit is reduced to 13.5 cooling kilowatt, that is 3.83 TR according to HAP calculations. That is around 46% less than the VRF capacity. Remember, here we have not considered partition within the floor, diversity in equipment load, and diversity in lighting. As in the previous presentation, the 3000 TR VRF system should be compared to the 1500 TR chilled water system. By applying the right idea of design, we reduce capital cost along with significant energy savings. Saving the clean money and electricity leads to saving the nation's money and energy, which in turn leads to saving the world's cost and energy. Thank you. Signing off, Sugesh K. Bhaskaran, Senior Mechanical Engineering Consultant.